Yeah, hello everyone. Welcome back to the Deep Dive podcast, episode 2. And I'm excited to continue this journey where we break down complex code problems from the ground up, starting with fundamentals and working all the way to expert solution. Today we are tackling classic and interesting challenge, finding the minimum swaps to arrange a binary grid. Okay, so we need to find the minimum number of swaps need to arrange a binary grid in a specific order, and we will explore the problem carefully and understand the constraint and then develop both a straightforward and optimized solution. You know, and along the way, I will share insights on problem solving strategies, code design, and the performance consideration, all with clear explanation, and practical examples. So, whether you are just starting out or looking to sharpen your skills, this episode will guide you through the entire process. Let's dive in and solve the minimum swaps to arrange a binary grid problem together. Yeah, let's start now. As you see now, this is a minimum swap to arrange a binary. You need to read the problem carefully. So given an n by n binary grid, in one step, you can choose two adjacent rows of the grid and swap them. A grid is said to be valid if all cells above the main diagonal are zeros. And we need to return minimum number of steps needed to make the grid valid, or minus one if the grid cannot be valid. And the main diagonal of the grid is the diagonal that starts at cell 1 1 and end this at cell NN. Okay. As you see the example 1, this is our grid, and we can swap row 1 with row 2. This is row 1 and this row 2, so that the both of these ones will already come up to this first row, and we can swap. So the one here and the one this already come down. So and then swap row 2 with row 3, and so on, swap row 1 with row 2 until already the above diagonal, all of them, yeah, as you see now, zeros. Okay, yeah, this is a grid cell is said to be valid if all cells above the main diagonal are 0. Okay, and this is the already first one. We already do this is by three step, so we need to return the minimum number of steps needed to make the grid valid. Yeah, we reach it to valid after 3 step. Okay, and here, yeah, all rows already the same, so we cannot, all rows are the same in our swap, have no effect on the grid. And also this one already perfect and valid, yeah, from starting, so we don't need do anything. So, and this is a constraints, we need to take care about the constraints. Yeah, so the grid length here within range from n until the grid of I dot length. Okay, and the n within range from 1 to 200, and the grid of ij is either 0 or 1. Yeah, it is just binary. And there is some hints here, you can check it if you stuck in something, if you need to check something. Also, for each row of the grid, calculated the most right one in the grid in the array max right, and to the check if the exists answer, sort max right, and check if max right of I less than of I for all possible y's. So if there is exist an answer, simulate swaps. Yeah, as we know, we need to follow structure approach for solving this problem during the interview. So first thing, you need to understanding the problem. Yeah, to first thing, you need to step this one to understand or repeat the problem again or restate the problem. Okay, you need to understanding the problem. After that, we can already now repeat or restate the problems to ensure we are on the same page. So we are given an n by n binary grid, yeah, as you see now. And in one step, we can swap any two adjacent row, and the grid is valid for every row I. All, yeah, I think this is valid when all cells in column 0 to I minus 1 are 0. Okay, and all cells above the main diagonal are 0. This is what we need to do. And we need to return the minimum number of swaps to make the grid is valid, or minus 1 if impossible. Yeah, if you're thinking about these problems, this is related to array matrix, and also something related to gradient and simulation and so on. So Second thing, you can already walk through on some examples, okay, or asking some clarifying question. Yeah, I think I prefer to ask question at the beginning, okay, to ready to gather all information and to really remove any ambiguity and so on. So before we move forward, so we can ask some question like are already we granted that the input grid is always squared n by n, for example. This is one question, and you can ask about can we swap any two rows or only adjacent rows? As we mentioned here, it is adjacent, okay, and the grid always n by n. So we are here square, and we are here n by n. Yeah, just a question from the requirements. You already see some answers. You need to check and you already confirm you are understanding the problem. Perfect. Okay. So next one, should we return -1 if it's possible to make the grid valid? Yeah, this is one. The grid contains also only zeros and ones. You need to read the problem and generate the question. Yeah, not just for asking the question, but yeah, be careful or you need to ready to remove any ambiguity. Not just a question. You can already asking some question. Yeah, maybe about the constraint input, output, and so on. But if this question are smart word, this is will be yeah added points for you. And yeah, are there any constraints on size? Yeah, as we mentioned below, here it is in the range from 1 to 200. And also we need to check if the grid always find fills with ones and zeros. Here it is mentioned zeros and ones. So it's yeah, our assumptions here it is okay. Based on the problem description and typical constraint, we can adopt the following assumptions like the grid is always n by n, and also all the adjacent rows swaps are allowed. The grid contains only zeros and ones, and the return one -1 if impossible. Okay. Okay. After asking the question and walk through some examples, you need to handle the edge cases. Okay. So yeah, you need to check about the edge cases. Anything will cause some issue in your solution or in your way. Okay. So maybe all rows already valid. This is return zero as we see here, and maybe impossible to arrange. Yeah, we can do -1 like this one. And if we have in for example single cell, this is always valid, return zero. Okay. And maybe rows with all of them zeros. Okay, this is already valid. And maybe we have rows with all ones above diagonal, this is impossible. Okay. And maybe you have you can think about the multiple rows needing to be moved to the bottom and so on. So this is a problem. We need to thinking about the approach. How can we solve this problem? Yeah, I thinking about this. I read the problem before starting the solution and before starting record. So I will share with you my thoughts here for this problem as maybe as a high level. Yeah, for each row, for example, for each row I count the number of trailing zeros. Okay, and then to satisfy the condition for row I, it must have at least n -1 minus I trailing zero. So for each row, I will find the first row below it satisfies. Okay, satisfies the condition and swap it up. Okay, so yeah, we can for each row count the number of trailing zero, and for each row I will find a row j greater than or equal I with enough trailing zero, and I will swap row j up to position I, count the swaps, and if no such rows exist, I will return -1. Yeah, I think this is for me as optimized solution. Okay, and maybe this is also as a broad force. I think the broad force it is already something efficient. Okay, for the given constraint in less than or equal 200. Okay, this is based on constraints. So I think no further optimization. Maybe it is just one solution for this. And yeah, yeah, I'm just trying to avoid unnecessary swaps by using a list or something like that. Okay, so yeah, yeah, and this solution always finds the closest valid row and moves it up, minimizing swaps and so on. The time complexity here will be big of n square. Okay, and the space complexity will be big of n. Okay, I think this is my solution. We can use also, yeah, I think it's the same, but we can change using linked list, for example, for faster swap, but vector is sufficient for n less than 200. Okay, and yeah, we can now after okay, we can starting with the already starting code after get the confirmation. Okay. Okay, let's start now to coding. Yeah, after I think handle the edge cases and share my thoughts here. We can starting, we can already calculate the complexity during discuss the approach. Complexity, and then last thing you can starting code, and last thing we can sorry tracing the code or run the code anything of them. So we can starting now to solving this problem. Okay, so let's start with the get the size of the grid. This is number of rows and columns. Yeah, and we can discuss also step by step the complexity during it. So in equal grid dot size. Okay, this is as a big of one and big of one. There is no anything else. Yeah, so this is already get size of grid. So big of one as a time as and as a space is just a line, and we can already vector to store trailing zero count for each row, and this is vector. Oh, sorry, I get then vector of integers. This is trailing zero. Trailing zero here will be store the n all of them zero. Okay, so we need to trailing count trailing zeros for each row, zeros for each row. Okay, yeah, this is line is as a space, and the com and the time will be take the big of n and the big of n also. This is as a vector. Okay, and yeah, we can starting now count trailing zero for each row. So I will trade for and I equal 0 and I less than n and plus I. Okay, and at this one I will initialize this loop over each row, and I will initialize count of trailing zero for current row. Okay, so I will change count equal 0, and then I will iterate again loop from last column to first. Okay, for and j equal n and j less than, sorry, greater than or equal 0, and we will minus j. Okay, so now look from last column to first, so we need to check if cell is 0. I will increment count and so on. So I will check if grid of phi of ij, if grid of ij equal 0. At this point I will count plus, and else I don't need anything, so I will here already stop counting when one is found. Okay, so I will break here. Break. Okay, this is first one. Okay, and then after this for loop I will already store trailing zero count for row I. So trailing zeros of I. Okay, phi equals count. This is I will store, as I told you, store trailing zero count for row I. Okay, and then this for loop. Okay, for me, yeah, and I need to initialize total swap counters, total and swap, and swap equal 0. And for each row here I wanted to ensure it has enough trailing zeros. So for int I equal 0 and I less than n and plus I. Okay, and this one I need to calculate required trailing zero for row I. So int needed here, as we mentioned in the approach, n minus 1 minus I. Okay, and then I will start searching from current row. So I will sign into gi, and I will find the row. Here it's just I will find the row j greater than or equal I with enough trailing zero. So while j is then n and then trailing zeros of j less than needed. So in this case I will j plus plus. Okay, this is find the row j greater than I or equal I with enough trailing row. So we will check if no such row found. I will return -1. If j equal n, so I will return -1. Okay, and we can swap the found row up to position I. At this case this is points. So while j greater than I will swap the trailing zeros of j with the trailing zeros of j -1. Okay, and then I will swaps plus plus. Okay, and j minus minus. Then I will return, at this case, return swaps. Okay, and yeah, I already called it swaps. Okay, swaps. Yeah, now I think it's okay. Let's just check it. And okay, training and swaps. Okay. Yeah, so let's run and check if there is any error. Okay, runtime over error. So let me check and come. Yeah, the error, I get the error here because I didn't add n -1. I adjust in. So the error, yeah, this causes maybe there is a head buffer overflow at this line. Okay, so which is trailing zero find the equal count. So we need, this usually means the code is trying to access write to an index outside the bound of the training. So I run it now and it's okay with me, and let's submit it, and then we can already make the wrap up for this problem and the summary for the problems. It's okay now. Yeah, let's wrap up the problem together. Now it's okay. Yeah, I think let's wrap up the problem again and the solution. So we given an n by n binary grid, swap adjacent rows to make all cells above the main diagonal 0, and we need to return minimum swaps needed or -1 if impossible. And our solution here, for each row count trailing zeros, and row I needs at least n -1 minus I trailing zeros, and from top to bottom we need to find the row below with enough trailing zeros and swap it up. So count swaps during this process, and if no settable row found, I will return -1. The complexity here, time big of n square and the space big of n, and this is a great approach, works well for n less than or equal to 100. And we handle the edge cases like already valid or impossible grids. And yeah, this is simple, efficient, and easy to implement. Okay, yeah, I think this is our solution, and this is our problem today. Thank you so much, and see you in the next episodes. Bye bye.